Okay, I hope everybody had a good day today. I know a lot of people have been sick from class, so hopefully we're not giving each other some kind of bug. But anyway, today is part 2 of week 5 for LTEC 213, and we're going to be discussing series circuits and potentiometers. The abbreviation for potentiometers is POTS. POTS are used extensively in all different aspects of electronics and electrical systems. In your book, when you read about variable resistors, or POTS, they'll sometimes be referred to as potentiometers and sometimes referred to as rheostats. Okay? They effectively do the same thing, and what that is they allow you to have a resistor that you can change by twisting a knob or moving a slide or doing something mechanical. Okay? They also make potentiometers that are electronic, effectively, but we're not going to discuss those. We're going to leave the potentiometers that have a mechanical action required for the discussion for tonight. So, in our discussion of variable voltage dividers and series circuits, we've already, I think, beat series circuits to death about. We've been discussing them for quite a while, and just from your performances on the quizzes and your questions or lack thereof, I'm getting the sense that series circuits, you've pretty much got that down. So what we're going to talk about tonight is the actual potentiometer itself. Which again is really nothing more than a variable resistor. Now the way that you'll see this drawn in a circuit, let's just say that we had, a single DC supply that was 12 volts, and we had a load, and that load was a variable resistor, also known as either a potentiometer or a rheostat. But we're going to consider this one to be a potentiometer. The way that we draw it to signify that it's variable is we just simply draw a line at approximately a 45-degree angle directly through the resistor. That then indicates or calls for a potentiometer, which is a variable resistor. Okay? And the way that it's usually indicated or specified is that the resistance of the potentiometer is equal to 0 to, let's say 500 ohms. They make them in all sizes that you can imagine. 0 to 1,000, 0 to 50,000, 0 to 1,000,000, 0 to 20 million, 0 to just about any value that you want. And the nice thing is that if you're looking for a lot of control over your variable resistor, then you want to have the spread between its minimum and its maximum value be a minimum. In other words, if this is 50 million, then it's going to be difficult for you to get changes of 10 ohms each time that you turn the knob. Okay? Whereas if this goes from 0 to 100 ohms, then you're going to be able to affect changes of 10 ohms by turning the knob. Okay? In other words, the jump in increase or decrease of resistance is going to be affected by the range. Right? 0 always indicating a short. Now, what do they actually look like? Well, what they actually look like are devices that have a wheel. So I'm going to color that wheel in dark. And that, excuse my lack of artistic perfection, but that wheel right there, or that knob, is the thing that you turn to change the value of the resistance in the circuit. Okay? Now, when you come into contact with one of these potentiometers or POTS or variable resistors, what you're going to find is that it has three mechanical connections. There's one that's sort of in the center, there's one that's off to the left, and there's one that's off to the right. Okay? Now, if you make a connection, and I'm going to switch colors here to emphasize this. If you make a connection across this potentiometer between the outermost posts, so you connect it like this, and then you stick it into the circuit. Does anybody have any idea what value of resistance you're going to get?
0 ohms. Oh, short circuit? It's a short. No.
Well, I'm asking.
0
Everybody thinks 0 ohms?
Yes.
Okay. Now, if you were to take, and I'm not telling you whether you're right or wrong yet, if you were to take and connect these two leads together, what are you going to get?
Depends on where it's set to.
It depends on where it's set to. And let's say that you took these two leads and you connected those two leads together.
Short circuit.
Would it be the plus or minus kind of thing?
Okay. The way that it works with a potentiometer is if you connect the outermost leads together and then you connect the potentiometer in series with the rest of the circuit, you are going to get the maximum value of the potentiometer.
Say again.
What I'm saying is that if you connect the outermost leads together, if you measure the resistance between this point and this point, the value of resistance that you're going to get when you measure that is going to be the maximum value of the potentiometer. And we'll see that in lab. Okay? On the other hand, if you connect the center post of the potentiometer and the outermost left post of the potentiometer, you're going to be getting one extreme, either the low side or the high side. So let's say that this can go from 0 to 500 ohms. And let's say that you had turned the knob so that the resistance between these two posts right here measured 50 ohms. So that measured 50 ohms. If this measures 50 ohms, then what does this have to measure?
500 minus 50.
500 minus 50. Or what is that? 450 ohms. Okay, so it's very important that you do not connect a potentiometer like this. And the reason is because you will then have no ability to control the resistance of the potentiometer. Okay.
What's up or down?
Well, you really have to measure it because it depends on how it's oriented inside the casing of the potentiometer. Some of them, you turn them clockwise and it goes up between these 2 points. And some of them, you turn them clockwise and it goes up between these 2 points. Okay? But usually, if you buy a batch of potentiometers, they'll be the same. Okay? It's just that some of them are made in reverse so that, you know, if this side, as you turn the knob to the right or clockwise, this side will go up and this side will go down, and then sometimes vice versa. Okay, so that's something that you have to experiment with by connecting an ohm meter to the two leads that you're going to use, and then twisting the knob so that you know is it going up or down. What I'm saying is if you connect an ohm meter between the two outermost leads, you're going to get the maximum opposition to current flow that the potentiometer is rated at. Okay? Now that's a little different than how you'd wire it in the circuit. So there is some truth to, if you wired it that way in the circuit, it would short. But what I'm really getting at is what happens to the value on your meter if you connect your meter. In other words, if this is your meter, and this is your potentiometer, and you turn it clockwise, and you have 3 leads, and you set your meter to measure ohms. So your meter is measuring ohms. And then you take one lead from your meter and you connect it here, and you take the other lead from your meter and you connect it here. And you turn the knob, the value of ohms will not change. It will be its maximum. If, on the other hand, you take your meter and you connect it here, then as you turn the knob on the potentiometer, this thing will change. 42, 47, 80, 100, whatever. Okay? And the value of resistance here plus the value of resistance here will be equal to the total resistance, or the highest setting of the potentiometer that's possible. Okay? How many of you have used potentiometers before? Okay, well, let me say one thing about potentiometers. They're really easy to work with. They're really easy to hook up. Once you experiment with them a little bit in the lab, play with them, you'll see how easy they are to deal with. There is a temptation in a lot of cases to solve circuits by sticking potentiometers in all over the place, instead of using the basic principles of physics and conservation of energy that we've learned in here, like Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law. Instead of using those basic physics principles, if you just stick potentiometers into a circuit, it is possible to figure out what the values of resistors should be. Like, as an example, let's look at our loaded voltage divider for just a second. Our loaded voltage divider had one light bulb in the bottom, and if you recall, it was rated for 6 volts and 200 milliamps. And then up here, we had another light bulb, and it was rated for 14 volts at 80 milliamps. Okay? The temptation is this. The temptation is, rather than going through the trouble of analyzing the circuit to calculate what R1, R2, and R3 should be, let's do this. Let's just stick in a variable resistor here, a variable resistor here, and a variable resistor here. And I'll control these two, and then you control this one. And then we'll watch the light bulbs, and when they both look like they're at full brightness, we'll stop. And then we'll take this potentiometer out of the circuit, and let's say you were hooked up between these two leads and you left this one open. So between these two leads is effectively your resistor. Then you can measure what value of resistance worked here, and what value of resistance worked here, and what value of resistance worked here. Now, if you're dealing with an extremely complex circuit that is very, very difficult to analyze, and all you're doing is trying to establish a baseline, you know, the maximum voltage it can handle or the minimum voltage that it needs to operate, then it's okay to use a potentiometer in a situation like that. This right here, in a lot of companies, will be frowned upon highly. Okay? Because what this is telling somebody who is a manager, supervisor, foreman, superintendent, whatever, what that's telling them when they see you doing this, to figure out, you know, what the value for R1 should be equal to, how many ohms. When they see that you're doing it like this, they think that you don't understand how to do it the other way. Otherwise, why would you be doing it this way? Because what you find is that if you tried to do it this way, it would take a lot of time and it would be difficult. And you ultimately would probably come up with numbers that were different, and when you went ahead and put those values in, the brightness of these bulbs would not be equal to each other. Okay? So just a word of caution. Don't think that because we have variable resistors that we don't have to analyze circuits anymore. We do have to analyze circuits, because the difference between this and the stuff that we've been learning so far is the difference between somebody who can go out and can set up a circuit and have already predicted how it's going to operate before they get into the lab or get out in the field or climb up the power pole or wherever they are, in the power plant, the nuclear power plant, whatever they're doing. Okay? And the person who has to go out in the field and hook something up that they can vary so that they can figure out, you know, what value should be inserted or what value should be substituted in order to make the equipment work. The latter is dangerous. The former allows you to come out to the field with everything that you need, de-energize the whole circuit, and then put in whatever you need, energize the circuit, and be very confident that it's going to work exactly the way that you designed it. Okay? Questions? Okay. Now, the main difference between the potentiometer and the rheostat is simply that once you get to a certain power level, and it depends on what company you're buying it from, but once you start to get to a certain power level or power rating for the potentiometer, then it's going to change names. And instead of calling it a potentiometer, they're going to call it a rheostat. So generally, you will not find rheostats that are rated at very small power ratings, you know, like half a watt. You're generally not going to find rheostats that are rated for 0.5 watts. On the same hand, you're not going to find potentiometers that are rated for 5,000 watts. If you're looking for some kind of a variable resistor that's rated for 5,000 watts, you're almost always going to see that described as a rheostat, not a potentiometer. Okay? But really the function of it is not much different. Okay? Okay. I see that our time is just about expired. So everybody have a good night. Drive safely. If you have any questions or need individual attention, come on up and we'll get you squared away.